This is a dragster, the fastest drag racing vehicle on the face of the earth. It's also one of the fastest vehicles ever made by mankind to move on the surface of the earth. That's because these vehicles accelerate to speeds over 500 kilometers per hour. Yes, 500 kilometers per hour. They accelerate from 0 to 500 kilometers each in under 4 seconds and reach 100 kilometers from each in just 0.5 seconds. This is so supernatural that the driver experiences a force of 5 to 6 G during the start, which means 6 times the force of gravity. At that moment, a driver weighing 80 kilograms suddenly weighs 480 kilograms. This acceleration is greater than any acceleration that can be felt in any other vehicle on Earth during the start, including fighter jets with afterburners on, rockets, and even some missiles. Equipped with a monstrous V8 engine with 11,000 horsepower, they consume about 5.7 liters of fuel per second. At the lowest power, their consumption is higher than that of a Boeing 747 during takeoff. This fuel isn't delivered by a regular pump, but by a super pump, and it's not just any fuel. These vehicles use a special fuel called nitromethane, which already contains oxygen in its molecular structure. This allows it to burn much more violently, but with less use of atmospheric air, which translates into more power. Combined with the fact that this fuel burns at higher temperatures, about 2,400 to C versus 1,950 dis for gasoline. This also means more power. The torque, or rotational force from these engines, is so strong that cars visibly shake into form in the first seconds of launch. It's similar to when we wring out a cloth to remove excess water. These engines produce so much exhaust gas that the gases alone generate 450 kilohours of downforce, that is downward force, which presses the car against the asphalt. That's because the exhausts are cleverly directed upwards and slightly backwards to create this force. This force is added to the 5,400 kg maximum downforce from the rear wing when the vehicle is at 531 kilometers per hour and the 320 kilos by the front wing, totaling about 6.1 tons of downforce generated at high speeds. This means that at extremely high speeds, the car is firmly stuck to the asphalt. And that's partly why these cars don't lose grip or take off, despite the high speeds they reach. By definition, a dragster is a type of lightweight vehicle, usually weighing just over a ton, including the driver, with extremely powerful engines. Specifically designed for drag racing. They appeared in the United States in the 1960s. They were designed for high speeds, above 500 kilometers per hour. The races contested by these vehicles are divided into 4 categories: Pro Stock Motorcycle, Fun Car, and Top Fuel. However, I will focus on the latter as it is the most violent of all, and the one that features the most insane and fastest drag cars in the world. One of the first things that catches your attention in a Top Fuel dragster is its shape, which is not about aesthetics, but rather the result of pure engineering. Every detail was designed to reduce air resistance, increase stability, and maximize traction at launch. The long and narrow chassis, just over 7 meters in length, helps prevent the car from lifting its front end when brute force is used at launch, while the narrow shape reduces aerodynamic drag, that is, wind resistance. The long distance between the rear and front wheels helps prevent the front wheels from lifting too much during a powerful launch, and the car lifting off, just like what happened with this car during a drag race. The entire vehicle is made of several chrome steel tubes which work like a huge cage, protecting and helping to reduce the impact energy in case of accidents or explosions, thus protecting the driver. In turn, the driver is positioned more towards the rear of the vehicle, surrounded by a structure that contains a combination of chrome steel, titanium panels, carbon composites, and Kevlar. This provides maximum protection from extreme acceleration, deformation, rollovers, engine explosions, debris, and temperatures over 1,000 degrees C. And the entire structure is quite lightweight for greater performance gains. Speaking of the engine, it's the vehicle's key component. Located right behind the driver, it is basically the most powerful piston engine in the world and also one of the most dangerous engines in the world. That's because they're quite unpredictable. Forged from aluminum, it houses pistons, connecting rods, and a crankshaft. Just like in a conventional engine, the difference is that everything is much stronger and more resistant compared to a conventional engine. While a conventional car has a spark plug for each cylinder, where the energy that generates the spark in the plug comes from the car's battery. A Dragster engine has 2 spark plugs per cylinder, totaling 16 spark plugs in all, with each pair powered by 244-amp magnetos. That's enough current not only to kill someone instantly, but also the arc they generate is so hot it can be used for welding. Magnetos are independent electrical generators that produce high voltage to ignite the spark plugs without relying on a battery. They are extremely powerful with output over 40,000 volts, because nitromethane is harder to ignite than gasoline or ethanol. At full load, spark plugs last only 3-4 seconds before melting or burning up. But the engine keeps running by inertia and by the incandescence of the nitromethane itself. The tremendous force these engines generate not only melts the spark plugs, but all the engine components end up suffering excessive stress, which results in severe damage, forcing them to be completely rebuilt. After each race, cracks form in the pistons and the piston crown melts. Cylinders suffer excessive wall wear. Oil ends up being burned along with the fuel. The crankshaft may become microscopically bent or experience joint fatigue. Connecting rods can stretch, bend, or even break, throwing pieces out of the engine block. All this can happen if the engine doesn't blow up immediately. The fuel that powers all of this is nitromethane, which is a mixture of 90% nitromethane and 10% methanol. With a very high calorific value, this fuel is known for its high combustion rate and its ability to generate a large amount of energy. Nitromethane burns with a much hotter and much faster flame than gasoline, and it can even keep burning in the exhaust in the absence of oxygen, producing a bright white flame. In 1 3/5-second race, a dragster uses about 60 liters of nitromethane. That's 15 liters of nitromethane consumed per second. Inside the cylinders, temperatures also exceed 1,000 degrees. In addition, the parts must be custom made and with clearances to compensate for thermal expansion. This means the engine experiences in seconds what a conventional car engine endures over hundreds of thousands of kilometers. Delivering 15 liters of fuel per second or 900 liters per minute is a major engineering challenge. That's why dragsters don't use an electric fuel pump like regular cars, but instead use a high-flow mechanical pump driven directly by the engine's crankshaft. This ensures that the pump's operating speed is directly proportional to the engine's rotation speed. This prevents the engine from running out of fuel or receiving too much fuel and causing a hydrolock, an extremely dangerous condition for any engine, which has already been discussed in a video here on the channel. Nitromethane lubricates the pump since there is no internal oil. The pump uses special aluminum, titanium, and steel alloys treated to resist nitromethane's chemical attack. The Dragster also relies on a supercharger. It allows absurd amounts of air to be sucked in and sent directly to the engine's intake manifold. In that way, the engine gets much more air to mix with the fuel and perform the combustion. Sticking out a lot from the engine and weighing about 100 kilos, it forces approximately 14 milliliters of air per second into the engine. That's enough to fill a whole room with air in under 2 seconds. The pressure generated reaches 4.5 to 5 bars or 65 pounds per square inch above atmospheric pressure. This means the engine gets almost 5 times more air than it would naturally suck in. Without it, the engine simply wouldn't be able to burn 60 liters of fuel in 4 seconds or reach over 11,000 horsepower during a race. While regular cars have a gearbox, also called a transmission, which is the vehicle's transmission system, which is a set of mechanical components whose main purpose is to store or transfer, in a controlled way, the torque produced by the engine in rotation to the wheels, changing the speed or direction of the shaft's rotation as the driver shifts gears. The Dragster does not have a gearbox. The engine's power is transmitted directly to the wheels, passing only through a clutch. The clutch, a mechanical part in manual transmission vehicles, connects and disconnects the engine from the gearbox. In other words, the clutch allows or prevents the engine's rotation from turning the wheels if the clutch pedal is released or pressed, respectively. Therefore, in Dragster, the clutch is used as a power control system in the first seconds of the launch, preventing the engine's full power from being released all at once to the wheels, which would make them spin excessively and destroy them before the vehicle even moves. It usually has 5 to 7 large carbon fiber and steel discs. Each disc is pressed against the other by a set of springs and centrifugal arms. The car starts with the clutch still partially disengaged, and with each hundredth of a second, the clutch goes from almost released to fully locked. The driver doesn't control it with his foot. An automatic clutch system handles everything. This makes the car go from 0 to 530 kilometers per hour in less than 4 seconds without causing the tire to spin excessively. Tires are another crucial part of the vehicle. They impress not only with their nearly 1.2 meter size, but also with their performance, since they are certified and capable of taking the vehicle to speeds over 530 kilometers per hour in 4 seconds without exploding. Something unthinkable for any other type of tire. Made almost exclusively by Goodyear Racing for all Dragsters, they are a true work of engineering. Unlike regular cars, where the tire is held in place and rotates only due to the internal pressure of the tire, in Dragsters, that wouldn't be enough since the internal pressure is very low, only 0.6 to 0.9 bar. The massive forces could rip the tire off the wheel. That's why they use a ring system which is bolted with more than 30 bolts to lock the tire to the wheel. This way, the tire doesn't spin freely on the wheel or get thrown off during the launch. And during the launch, you can see that the tires deform and wrinkle in the very first seconds. This happens because of the low air pressure with which these tires are inflated, which is only 6 to 10 psi compared to a regular car, which is inflated to a pressure of 30 to 35 psi. This low pressure allows the tire to deform, creating a larger and flatter contact area at the start, providing maximum grip and traction. As the car accelerates, the centrifugal force expands the tire, increasing its volume and reducing friction, which increases the top speed. Another reason for low pressure is to reduce the risk of tire blowouts right at the start. because if they were fully inflated, they could spin excessively and blow out even before the vehicle starts moving. Before the race, the drivers perform a burnout with the tires to heat up, clean, and apply a fresh layer of rubber to the track surface to optimize grip. In addition, two technicians also sequentially clean the tires by hand to ensure there is no debris stuck to them, which could cause problems such as blowouts. And since dragsters don't just live on acceleration, they also need somehow to safely lose all that speed and stay within the track. For that, even though they have brakes that are more robust than those of a regular car. The main braking system is the parachute, which is deployed right after the driver crosses the finish line. Each dragster has two parachutes, a main one and a safety one in case the first fails. The parachute is deployed by compressed air cartridges or springs, opening in a fraction of a second. The braking force of the parachute can generate up to 5 to 6 Gs of deceleration. Due to the high force and performance required in this sport, accidents are almost always present. There are all kinds of imaginable accidents. Many of them happen even before the race starts, with an explosion or catastrophic failure in the engine itself. Many times, it's the tires themselves that explode before or during the race, which usually leads to a catastrophic and sometimes fatal accident. At other times, the vehicle itself disintegrates or takes off due to the tremendous force of the wind, acting on the vehicle in the very first seconds of the race, which results in an equally catastrophic accident and the total destruction of the vehicle. That's why everything is constantly and continuously checked to reduce the chances of a failure or accident occurring. And despite the violence of the accidents, constant deaths just don't happen, because besides the event's high safety standards, the vehicle also acts as a cage that protects the driver. In addition to a series of safety equipment that the driver uses, such as a fireproof suit, helmet, gloves, multi-point quick-release seatbelt, onboard fire extinguishers, as well as a fuel tank, lines, and connections, resistant to damage among several others. In fact, a top-fuel dragster is the most extreme form of race car ever built by humans. It's not built for corners, comfort, or durability, just a single purpose: to accelerate as fast as possible in a straight line for 402 meters, that is, a quarter mile. These vehicles represent the limits of automotive engineering and applied physics, combining supernatural engines with more than 11,000 horsepower capable of consuming absurd amounts of fuel per second. A violent acceleration creates 5-6 G-forces, taking the vehicle from 0 to over 500 kilometers per hour in under 4 seconds, something that no other land vehicle can do. Accelerate.